Right, welcome back. Let's see if we can do this thing again. I started here with the exercise 5, page 75, the homework that you did. You can look through all of them. I don't think number 1 was a big problem. Number B was still fine. In number D, they had to ask angles. In number B, you will see that I did that same thing of calculating the angle, and here I used interior angles of a triangle to calculate the third angle. Again, you could calculate angle theta saying sine is 6/10. So sine theta 6/10, and you can calculate the same value. Number G is very similar to the example that we did yesterday. There you have tan 40. You first had to calculate DC and use that DC to calculate angle theta, because to calculate angle theta I don't have enough information in this triangle. That's the reason why I first had to calculate this one. In number J, I don't have a calculator to help me, it's only letters. So they asked you to write sine P in terms of H and M. So sine P, I did not write the 90 degrees here. Sine P is opposite over hypotenuse, H/M. Sine R is in from here, H/N. But from there, both of them has an H. So H is M sine P, or H is N sine R, and therefore they are equal to each other. And in number 4, they asked you to calculate now angle P, and they gave you the values for the rest, so you just find P alone from here. By the way, if you couldn't do even number 1, 2, and 3, please never ever leave out number 4, because for number 4, I've asked you in number 3, prove that this is true. So even if you couldn't prove it here, you can still take this and substitute in that information given in number 3 to calculate, and you can still get your 2 marks for this question, even if you could not do anything of the rest. So please always keep that in mind. Right guys, another thing that we are going to look at is now closer to real life, is the angle of elevation and angle of depression. Now the angle of elevation, and I've written down the definition there, and I wish I could stand in front of you and say this whole thing that you must remember. Let's try this. For angle of elevation, you are looking at the angle that your eyes go from horizontal upwards. So always remember that you look from the horizontal line to go to that angle of elevation. So there's your angle of elevation from horizontal upwards. First example, the angle of elevation of the sun over the top of a tree is 30 degrees. So if the man stands 15 meters from the tree, so here I am, or the man, and there's our tree. I totally believe that you will understand why I'm not going to draw the tree. Right, we don't need to do that. We are going to say, but this tree is 90 degrees. Here's my little man standing there. So the angle that he makes, angle of elevation from horizontal upwards, is, and the man stands 15 meters from the tree. So I hope all of you can understand that that's my 15. So what is the height of the tree? I'm standing at 30. I'm looking for opposite. I have adjacent. So tan 30 is equal to H/15. To get H alone, I just multiply by 15. And the height of this tree, I can find my calculator, 15 tan 30 is, let's go for 8,66 meters. So there's our first real life situation. Now the more difficult one. Although the definition is not that difficult, the interpretation of this is most of the time difficult. Angle of depression is the angle with a horizontal line, the number of degrees your eyes go down if I'm looking at anything. So there is my angle of depression. Now, I know it looks very similar to my previous one, and it sounds very easy and obvious when we look at this. But the problem is, if we get to a question like example 2, here they ask me, a man is standing on a vertical cliff of 100 meters. Now let's say this is my cliff, 100 meters. Again, you understand that this is a cliff. The angle of depression to a boat in the sea. So here is my sea and there is my little boat. Thank you for all of you laughing. And I'm looking at this boat. Vertical cliff means 90 degrees. This all is sea. Question is, what is the distance of the boat from the foot of the cliff? So the angle is 75 degrees. Now where do you want to put that 75 degrees? Most of the time, all the learners want to put it there. But that's not the angle of depression. We said angle of depression is from the horizontal line. So I'm literally going to make an angle, a horizontal line there, and say from horizontal down, that is my angle of depression. Not this angle. And if you remember back to grade 8 geometry, we learned that alternate angles are equal. So my angle of depression is exactly the same as the angle of elevation from this side. And now everything is inside the triangle again. So please remember, this man standing here looking with an angle of 75 degrees down to the ship means this captain on the ship is going to look with an angle of elevation of the same size to this man as well. So my suggestion is that you always make sure, if your angle of depression is not currently in a triangle, so if this triangle did not go there, rather fill in the angle of elevation from the other side than trying to fill that angle in there. Technically, this angle there is going to be 15 degrees. Why? Because they must add up to 90. But we are not going to work with this 15. Let's stand here at 75. I have opposite. I'm looking for adjacent. So tan 75 degrees is opposite over adjacent. And I can calculate D. To get D alone, I'm going to multiply and divide with the tan 75. And I can calculate that I have 100 divided by tan 75 gives me 26.8 meters, or 79 if I round off to 2 decimals. I hope this is very clear to you, because this one is the most important part of today's lesson. An interesting one that unfortunately is not in the textbook, but I am going to ask something like this in the exam, because this is an application of both the angles that I've learned. Here I am standing on one building, and I'm looking at a different building opposite the street. These two buildings are, let's say, 50 meters apart. And now I'm going to give you information. I'm going to tell you the angle of elevation to the top of this. Let's make this AB a tower. This tower, the angle of elevation to the top of the tower is 15 degrees. And the angle of depression to the bottom of this building is, let's say, 35 degrees. My question is, what is the height of this tower? So let's do something with the 15 and the 35. Angle of elevation and angle of depression works from horizontal line. So do you agree that I'm going to fill in my own 90 degree or horizontal line here? And if I do that, I can say that now the angle of elevation is from there to there 15 degrees. And my angle of depression from horizontal down is 35 degrees. My question is, calculate this whole thingy. Now remember, this horizontal line is parallel to this horizontal line, so I'm going to make this my 90 degree triangle. And if this part there is 50, then that length from there to there will also be 50. So I hope you can see that this is very similar to the previous example that we did yesterday, where I now can calculate, let's make this one x and y. And I know that x plus y will give me the total height. So in this triangle I can calculate x, because I have that tan 15 is opposite over adjacent. Tan 50 opposite over adjacent, and I can calculate x 50 times tan 15. I'm not going to calculate the answer yet. I will tell you now why. If I work in the other triangle, standing at 35, opposite and adjacent, I also know that tan 35 is opposite over adjacent. So this y is 50 times tan 35. Now remember, earlier I said we never round off before the final answer. They did not ask me to calculate x or y. They asked me to calculate the height of this whole thing, which means that the height is going to be x plus y. And I'm not allowed to round off before I get to the final answer. So I don't need to write those answers down there. I can say 50 tan 15 plus 50 tan 35, and then in one answer give me get the answer of this. Tan 50 tan 15, close the bracket, plus 50 tan 35, and my answer is 48,41 meters. If you wanted to get the final answers of only those part 50 tan 35, you are going to get exactly the same answer, but the probability to make rounding off mistakes is totally too unnecessary. So why will I go there if I don't need to? This will give me 13,39, etc. And if I'm going to add 15 and 35, 35 and 13, I will get my 48, which gives us the answer that I wanted. Right, let's try to do exercise 6, page 78. And again, to next lesson, I will give you the correct answers on that one as well. Enjoy!